Hey guys, welcome to example 3 of 6.6. Let's get started. As you can see, I did some work ahead of time for example 3 just to kind of give you an idea of why we want to work in polar form with complex numbers. All I did here was figure out what cosine of negative pi over 4 is, and sine of negative pi over 4, cosine of pi over 3, and sine of pi over 3. Those are all values you know you can do in your head, and you distribute your radius, and you get the complex numbers, not in polar form, right here and here. If you were to have to multiply these, you'd have to distribute 25 times 7, there, that, and that. You'd have to work with an I squared. You'd have to combine like terms. Not difficult, but tedious. And imagine if then you had to multiply another complex number and another complex number. It's going to get ridiculously annoying to do. So if you had a bunch of complex numbers they'd define the product for, not fun, all right? So we don't want to come out of this section thinking that that's what we're going to do. The purpose of polar form is not just I shouldn't say purpose, but the super cool thing about polar form, probably shouldn't say super cool either, but the very useful thing about polar form is that this work is so much easier from the idea of the perspective of looking at it as an angle and a radius, right? So if you have an angle of negative pi over 4, you're pointing in quadrant 4, 25 root 2 units away from the pole, and then pi over 3, 14 units away from the pole. If you multiply those, all you have to do is multiply the two radii and then add the two angles, and that's it. So let's go ahead and do that. So z1 times z2, if I had it in polar form, would just be 350 root 2. That's just multiplying 25 root 2 times 14. And the rest of it would just be cosine, I sine, and we just take our two angles and add them. Negative pi over 4 plus pi over 3, negative pi over 4 plus pi over 3. And from that, it'd be 350 root 2, and it'd be cosine. Well, pi over 4 and pi over 3, if you get the same denominator, it's going to be over 12. Multiply top and bottom by 3 and top and bottom by 4, you're going to end up with a pi as your numerator, plus I sine pi over 12, and that's it. The only thing left to do is really just throw in your calculator if it's not ratios that you already know. So I'm going to just cheat and go to the textbook. Let's see, right over here. And it's 478.11 and 128.11. So let's get that. 478.11 plus 128.11. Do they put the I first or second? Yeah, second. Right. So all you have to do again is multiply the radius and add the angles, and that's it. After that, throw in your calculator if you need to. I don't know how much easier it can get, but it's way easier than than doing all of this multiplying out, especially in the next section when we're going to be doing it with exponents and basically repeated multiplication. You'll see how easy it is when we understand this property. I'll see you in example 4.